Good evening, dear students. So, we are going to start with a new topic in pharmaceutical engineering, that is size reduction. And in first two video lectures, what we have discussed in size reduction. In first lecture, we have discussed the introductory part of size reduction. In first lecture, lecture number 1, we have discussed the introduction of size reduction along with the factors affecting on size reduction and mechanisms of size reduction. This we already covered in first lecture. And in second video lecture of size reduction, we have covered, in second lecture, we have covered the two mills. First is hammer mill and next is ball mill. So these two mills already we have covered in a lectures, second lecture. Now we are going to start with a third lecture in the same subunit, that is size reduction, which is mentioned in the pharmaceutical engineering semester 3 of B pharmacy. So in fluid energy mill, we are going to start. So first important thing, what is mean by fluid energy mill, that we will start. So fluid energy mill, this mill utilize the high velocity air, which is generally inert air. Inert air is used. So high velocity inert air is used, and this inert air is actually responsible for breakdown of the particle. Already we have discussed in introductory part what is mean by size reduction. Size reduction is simply a breakdown of powder particles. So who is responsible for breakdown of the powder particle? That is high velocity compressed air. So high velocity compressed air is utilized, and this air is actually responsible for breakdown of powder particle. So far, in second lecture, we have already covered hammer mill and ball mill, and we have discussed in hammer mill, hammers are responsible for size reduction. In ball mill, stainless steel balls are responsible for size reduction. But this is quite different mill with respect to the, this mill is a different with respect to the other mills, with respect to the shape of mill as well as configuration. Both are different. Shape as well as configuration, both parameters are different in case of fluid energy mill if you compare with other mills. So why this mill is a very much special mill? Why? Because here the most important thing, in fluid energy mill, the movable part is absent. Movable part is absent. In hammer mill, we have covered the hammers are continuously moving, and these hammers break the particle by the impact mechanism. Then in ball mill, the stainless steel balls are continuously moving and the particles are break with the help of attrition as well as impact. But in fluid energy mill, the movable part is not there in the construction part. You can better we understand. In construction, we will discuss. So movable part is absent, means as such the movable part is not present in the mill. So who is responsible for breakdown of the powder particles? The high velocity air is responsible. So as the movable part is absent in the mill, so no heat generation. Heat generation will not take place in this mill, which was the drawback of hammer mill. In hammer mill, the continuously rotating hammers generate the heat, and that's why hammer mills require additional cooling facility, and it is not suitable for thermolabile drugs, heat sensitive drugs. But in fluid energy mill, so you can grind the heat sensitive drugs in fluid energy mill. How you can grind the heat sensitive drugs in a fluid energy mill? Why? Because no heat generation. Heat is not generated in this mill. So as the heat is not generated, though it is suitable for heat sensitive drugs also, heat sensitive powder material also. This is also one important special characteristic of fluid energy mill. So movable part is absent. It is very much different with respect to the configuration and shape than other mills, and as the heat generation not takes place, it is suitable for size reduction or grinding of heat sensitive materials. So this mill is also known as jet mill. Why this mill is known as jet mill? Because it utilizes high velocity air. So as high velocity air is used, and this high velocity air is passed through narrow apertures or orifice. So this high velocity air passes through narrow orifice and it forms a jet. and that's why this mill is also known as jet mill, or it is also known as micronizer, because it generates a very fine powder particles. That's why this uh, fluid energy mill is also known as micronizer. These questions, these terms, other terms for the fluid energy mill like jet mill or micronizer, these are important. Why? Because the question may ask in MCQ type question. Which of the following mill is also known as jet mill? The correct answer is fluid energy mill. Which of the following mill is also known as micronizer? Again, correct answer is fluid energy mill. So these two other terms also you have to remember. So as it is used for fine grinding, it generates particles of very much fine size range. That's why this is also known as micronizer, and it is suitable to get a powder particles with very much fine size range. Next, come to the principle. First important thing, principle of fluid energy mill. So fluid energy mill break the particle by again a combination of impact and attrition, like a like ball mill. In ball mill also, both mechanisms are responsible. Similarly, in fluid energy mill also, the particles are break by attrition as well as impact. So how impact is generated and how attrition is generated, that we'll discuss first. So as we discussed earlier, this mill basically utilize high velocity air. So this high velocity air is introduced from bottom of the mill through the nozzles. So this high velocity air is introduced in the mill from bottom, and due to the high velocity of the air, what will happen? The powder particles which we introduce in the mill from feed inlet, these powder particles remain suspended in the stream of high velocity air like this. So this mill basically consists of a hollow loop, and this is made in short hollow loop. This one in short a hollow pipe, and this hollow pipe is made up of stainless steel. What about the diameter of this pipe? The diameter is 20 to 200 mm diameter. Diameter of the hollow pipe. The diameter of hollow pipe is 20 to 200 mm. So the high velocity air is passed from bottom of the hollow pipe, and the pipe shape of the pipe is a elliptical loop. So due to high velocity air which we pass from bottom, what will happen? This high velocity air suspend the powder material. Suspend the powder material. So the powder particles also move through the hollow pipe at high velocity. So during movement, what will happen? The powder particles strike on each other like this. So we'll see the enlarged view. This is one powder particle. This is another powder particle. So these powder particles strike on each other like this and results in a breakdown of both powder particle. This is known as attrition. So fine powder particles you will get at the end like this. How fine powder particles is? That is collision between particles. So as the particles are moving with high velocity, the powder particles may collide with each other and results in a breakdown of the powder particles into fine powder particles. This is known as attrition of the powder particles. This is first thing, attrition. Now next come to the impact. How impact takes place. So how attrition takes place? The attrition takes place by the movement of the powder particles. That is collision of the powder particles with each other. And now next see how impact is takes place. So the wall of the stainless steel pipe, this entire pipe, stainless steel pipe is made up of, it is hollow and it is made up of stainless steel. So what will happen? During movement of the powder particles towards the upward in the stream of air, these powder particles strike on the walls of pipe like this. So suppose this is a wall of pipe and this is high velocity powder particle. So high velocity powder particles strike on the wall of pipe. So pipe is a stationary. Pipe is a stationary and particle is moving at high velocity. So what is mean by impact? In impact, either the moving powder particle strike on the stationary object or the moving object of the equipment strike on the stationary particle. This we have already covered in first video lecture. So here the moving powder particle strike on the stationary wall of the hollow pipe and results in a breakdown of the powder particle like this basically. So simply a high velocity powder particle strike on the stationary wall of the fluid energy mill, so wall of the pipe, and results in a breakdown of the powder particle. So both mechanisms are responsible for breakdown of the powder particle, attrition and impact. So now we have covered how attrition takes place, how impact takes place. So you can see here the entire assembly of the mill is stationary. Entire assembly is stationary and no moving part is absent. The hollow loop of the pipe is stationary. Entire hollow loop is stationary, no moving part is absent here. So as the moving part is absent, most important thing, heat generation will not take place and this image is suitable for breakdown of the heat sensitive drugs. Now let's see the construction of the fluid energy mill. So you can see in the construction, the fluid energy mill is made up of the hollow pipe. With this hollow pipe, the shape of the pipe is elliptical loop. Next important thing, it consists of the major parts. Which are the major part? The first part is a inlet for the air inlet. So air inlet. Where is the air inlet? Air inlet is present at the bottom. Through air inlet, what will happen? The high velocity air is introduced. High velocity air is introduced. This air means the gas is inert gas. Why inert gas is used? What is meant by inert? Inert means non-reactive. Inert means non-reactive. So during the size reduction, the powder particles are in direct contact with gas. As we discussed earlier, powder particles are suspended in the stream of air. So powder particles are in direct contact with the gas, and that's why the gas may interact with the powder particles and that may be responsible for chemical degradation of drug. And that's why we require a non-reactive gas. Why non-reactive gas is required? Non-reactive gas will not react with the powder material and the drug will remain in the active form. No chemical incompatibilities will be there. No chemical reactions will be there between the gas and drug material or powder material. That's why we require inert gas here. So inert gas is introduced through air inlet. Now next important thing, this inert gas is introduced through air inlet. This inert gas is generally a compressed gas. Compressed gas. So compressed gas is allowed to enter in the mill from bottom. Later on the compressed gas is passed through nozzles. So here is a provision to adjust the velocity of the air. So this compressed gas again enters in the hollow loop through nozzle. So here the once the air entered in the hollow loop, what will happen? Initially the air is compressed air. Initially the air is compressed air. So what will happen? Once the air is introduced in the loop, what will happen? Here the air expand. So expansion of air takes place. Okay, so expansion of air results in a cooling of the air, and this again avoid the degradation of a drug. Most important thing, heat sensitive drug. So no heat generation. Instead of heat generation, additional cooling takes place. This is first component. Next come to the second component is a feed inlet. Where is a feed inlet? Feed inlet is present at a site. So what is the role of feed inlet? To introduce a powder material. Okay. So powder is introduced through feed inlet, generally hopper, funnel shaped part, and later on powder is flow through this side tube with the help of a Venturi feeder. This is known as Venturi feeder. This Venturi feeder continuously rotate. A rotation of this Venturi feeder results in a movement of the powder through the side tube into the hollow loop. Next, we'll see. So this is in general image of the fluid energy mill. This image I have intentionally included because based on the image also you can better way understand how the fluid energy mill look like. Already I have discussed in diagram. So this is the image. So you can see here hollow elliptical loop which is made up of stainless steel. This is feed inlet. This is feed inlet from where the gas is introduced. Gas is introduced from the hollow pipe again you can see. So here you can see these are the nozzles to adjust the velocity. Okay. So powder material break within a hollow loop. Okay. Basic thing. So in construction we have covered two major parts. First is inlet and next is feed inlet. So the major part is a hollow loop of the pipe which is generally made up of stainless steel. Already we have covered the out about the diameter. Diameter is 20 to 200 millimeter. What about the height of the mill? As it is hollow loop, so height is quite more. You can see 2 meters. Already we have covered. It don't have any moving parts. So as moving part is absent, no heat generation suitable for thermal avoidance. So due to absence of the moving part, it is quite different than other mill with respect to the shape and configuration. The configuration and shape is also quite different than the other mill as well as moving part is absent. So it is quite different than the other mill. Feed inlet already we have covered. It is to generally introduce a solid material into the mill. Next come to the nozzle, second part. Where nozzles are present? Nozzles are present at the bottom. So through nozzle, the air or inert gas is introduced, which is also known as feed inlet. Barabar? So it is present at the bottom again of the mill. The next important component is a classifier. So two components already we have covered. Feed inlet, nozzles means the air inlet. Next is a classifier. Where is a classifier? Classifier is present at the top. You can see here. I will highlight with the help of marker. Here is a classifier. What is the role of classifier? Classifier as its name suggests. Classifier means classification. Classification means the separation. So classifier is nothing but a cyclone separator. We will cover cyclone separator means size separation unit. So classifier is nothing but a cyclone separator. And what is the role of cyclone separator? The role of cyclone separator is to separate out the powder particle. Means separation of coarse powder particles from fine powder particles. So fine powder particles are collected as a product and coarse powder particle you can see again enter in the hollow pipe and again undergo size reduction. So this movement of the powder through the hollow loop is continue till a desired size product is obtained. And that's why to separate out coarse powder particles from fine powder particles, suppose we introduce a coarse powder particles from here like this, quite coarse. Later on through the impact attrition again a fine powder particles you will get these fine powder particles and quite medium sized powder particles are also present. So fine powder particles are collected here. Okay, discharge chamber can, and coarse again enter in the mill like this. And this process is continued till a desired size product is obtained. And this is the role of classifier. Classifier is nothing but a separator. This is cyclone separator. Okay, classifier is a cyclone separator. What is the role? Role is to separate out the powder particles. Wherever fine powder particles are separated from coarse powder particle through classifier. So classifier basically collect the fine powder particle for discharge means for collection final product and leave the coarse powder particles in the loop as we discussed earlier for further size reduction means the movement of coarse powder particles is continue till the size reduction takes place means desired size product is obtained. Come to the working. Now I in introduction construction only we have covered the working. So solid material is introduced through feed inlet. Later on, the high velocity air, compressed air, inert gas is injected or passed through the nozzles from bottom where the actually the gas inlet is present at bottom. First of all, material is introduced, later on gas is introduced. So what will happen? Uh, as we discussed earlier, this is compressed air. So how much is the pressure? 600 kilopascal, too much high pressure, to 1 megapascal pressure of compressed air. So compressed air is means air is compressed at this pressure. So inert air is used as we discussed earlier. It prevents the oxidative degradation of a drug because air is in direct contact with drug. So chances of oxidations are more. So to prevent the oxidation, we require inert air, non-reactive air. So high velocity air basically cause the acceleration, means cause high powder particles are suspended in the high velocity air. So due to high velocity, the powder particles are also accelerates or move at high velocity, and due to the movement, what will happen? The powder particles, movement of powder particles at high velocity means what? Due to this movement, the powder particles strikes on each other, results in attrition. Powder particles strike on the walls of equipment, results in impact and results in a breakdown. So next important thing, why the loop has made. The loop like this, you can see. The hollow loop like this. Hollow loop like this has made. So due to the hollow loop, what will happen? So as the air and powder both move through the hollow loop, what will happen? It creates the turbulence. Due to the loop like shape, it creates the turbulence, and this turbulence of the air is additionally responsible for breakdown of the powder particles through collision of powder particles. Already we have covered. So one powder particle strike on second powder particle like this and results in a breakdown of the both powder particles into fine size particles. This is known as collision, means striking of the powder particles. SIOE, striking of the powder particles. So this striking takes place due to high velocity as well as turbulence. Coming to the advantages, very fine powder particles are produced because as it is known as micronizer, it produces very much fine powder particles compared to the hammer mill and ball mill. So particle size achieved by using classifier, cyclone separator. The according to size required. Sometimes the two cyclone separators are connected in series for better separation of powder. Contamination of product can be avoided. Why? Because it is completely closed equipment. So product contamination cannot be takes place. The sterility of powder can be maintained, provided air should be sterile. Heat sensitive material you can grind as no heat generation takes place. Additionally, cooling effect is produced due to expansion. So heat sensitive material you can grind, and this equipment is easily sterilized by gas sterilization. After utilization of equipment, the equipment is easy to sterilize by simply passing the gas through the equipment. Means hollow pipe can be sterilized. Coming to the disadvantages, more energy consumption. Where energy is utilized for compression of the gas. So energy consumption is more compared to other mill. More head space, as we know the height is 2 meter. So head space requirement is more. It occupies more space. Two types of space are there, head space and floor space. Here head space requirement is more because height is more. Not suitable for tacky and sticky material. Why? The tacky sticky powder material will not suspend effectively in the stream of air, and that tacky or sticky material may adhere to the inner wall of the pipe because of sticky nature. So it is not suitable for tacky and sticky material. These are the disadvantages of ball mill. Thank you.